So today we discuss about the different position of image, how the different position of image can be formed due to different position of object by a concave as well as convex mirror. And in previous class we discussed how the mirror formula can be established, that is the relation of 1 by V plus 1 by U is equal to 1 by F, and the magnification of mirror, that is magnification of mirror, that is the ratio of height of the image and height of the object, height of the image and height of the object. So now we draw this ray diagram, that how the images can be formed for the different position of objects. For a first time we draw for a concave mirror. পিকচার ঠিক আছে তো? Now first we write down the heading, that formation of image by a concave mirror. First you write down a heading, that formation of image, formation of images by a concave mirror. Formation of images by a concave mirror. Next we discuss about the convex mirror, how the image form to a concave mirror. Okay, now let us draw a concave mirror. The outer portion is shaded and the reflecting portion at the inner portion of the mirror and suppose this is our principal axis. Okay, now this is our first consideration, that if we consider this is focus and this is center of curvature, double of its focal length, f is equal to r by 2, which is we can prove by using ray diagram. এটাও তো আমরা করেছি. Now if the object is placed, that is u is greater than r or u is greater than twice f, that is if the object is placed beyond the center of curvature, in between infinite and the center of curvature. Is it clear? In between infinite and the center of curvature. Now suppose this is a parallel ray which is incident, this is a parallel ray which is incident on this mirror and focal length. So it is reflected from the point of incident and it goes through the focus length or the focus point, like this way. Okay, understand? Now we can draw another ray which can be incident on the pole and it can be reflected, and we can also another ray which is incident on the center of curvature, on the center of curvature also. Now if we draw a second ray which is incident on this pole like this way and is reflected with making same angle, and they are they are intersect at this point where the image of this point can be happened. Suppose this is AB and this can be written as the image of the B point, that is B dash, and the image of A dash B dash can be drawn like this way. Okay, so this is our first case where image is formed in between C and F, okay. Now this image is real or virtual? The nature of the image is, the image will be real, because these two rays are directly intersect.
It formed inside of the object.
In front of the mirror. It form at the front of the mirror, or these rays are directly meet at the B dust point. That's why the image is real. And the height of the image is reverse, that is the length, the height of the image, or this B point is formed at inverted from this invertedly with respect to the principal axis. That's why the nature of the image also can be written as inverted. Okay. The direction of the height in opposite with respect to the principal axis. And the magnification of the image, what is the magnification of the image? And it should be, what is the magnification of the image? It should be diminished or smaller. It should be diminished, because here V less than U, and we know the relation, that is M is equal to V by U. Magnification M is equal to minus V by U. Then if V less than U, then we can write, if V is less than U, then we can write that M is less than 1. M is less than 1. So this is a smaller type of image. Okay. Now the first position of the image should be considered at infinite. If we consider that the position of the object at infinite, then image should be formed at the focus of the mirror. Is it know that how the image can be formed at the focus of the image when the object is placed at infinite? Suppose if we consider this is the second condition, and the first condition, if the object is placed at infinite, U is equal to infinite. If U is equal to infinite, then the rays are which are incident on the mirror are paraxial rays are incident, paraxial rays are incident on the mirror. That's why all the rays are meet at the focus point. So this kind of image is real also, and it can be virtual for convex mirror. Now how can we define actually if the position of the object U is equal to infinity? From the mirror formula we know that 1 by V plus 1 by U is equal to 1 by F. Then if we put that U is equal to infinite, then from this relation we can write that 1 by F plus 1 by infinity is equal to 1 by F. So V is equal to F. That the image is formed at infinite. And the point of magnification of the image is very small, because we know that M is equal to V by U. If U is equal to infinity, any number divided by infinite is equal to tends to 0. Tends to 0 means this is the actually the magnification of the image, that is the dimension of the image, size of the image is very small. It like it to be a point. Okay. Now this is our second condition. First object is placed at the infinite, then object is placed in between infinite and radius of curvature. Now object is going towards the mirror. Now if the position is at 3, position where U is equal to R, that is U is equal to twice F, that means center of curvature. Center of curvature. Then you you if specifically u is equal to twice f, then if u is specifically twice f, then what is the image of, what is the position of the image of this object? Now if we draw a mirror like this way, position of the image also in center of curvature. So suppose this is our f and this is our c. This is our c, center of curvature, and the object is like this way. Then if we draw a para-axial ray from this B point, this is a B point, and it should be goes through the focus point. And another ray, if we draw at the pole, then we can draw which is from also center of curvature. It should be from at the center of curvature. If we draw this ray like this way, okay, now the image is from at B test. Actually we can calculate the position of V mathematically. If we draw by using proper measurement of f, and the twice value of f is c, and properly parallel to the principal axis, that is the para-axial ray which is released from B point, and this angle is absolutely same. If we draw a scale compass to draw this picture, then the point should be meet just below of the below of this point B test. But if we draw a normally like this kind of a drawing, then it may not be particularly meet at the just below of this B point, but mathematically we can show that V is equal to half, V is equal to twice f, or V is equal to R by using this mirror formula. That is, we know that 1 by V plus 1 by U is equal to 1 by f. Then if we put the value of U, as twice f, then if we put the value of U as twice f, if we consider the sign convention as f is equal to U is equal to plus twice f, and if we consider the sign convention f as U is equal to minus twice f, then this f should be also minus, because here position of the focus and the position of the object in the same direction from this pole, that is the opposite direction of the incidence light. Okay, that light is incident on this direction, and if we measure the position of the focus and the position of the object in opposite direction of the incident ray, then you may consider that the U is positive, or you may consider that U is negative. Then if we consider U is positive, then U is equal to twice f. If we put the value of U is equal to twice f, then we get that 1 by V plus 1 by twice f is equal to 1 by f, that is 1 by V is equal to 1 by f minus 1 by twice f, that is equal to 1 by twice f, that is V is equal to twice f. Okay, so we find out this formula from this formula, that the position of the image at the same position of object. V is equal to V is equal to 2f. If we put the value U is equal to twice f, then we get the value that V is equal to twice f by using this mirror formula. Okay, now from this ray diagram or the mathematical form, we may write that the position of the first, we write down the position of the image at same position with the object at center of curvature at C, the position of the image at C, that is V is equal to and the size is same also, because they are U and V both are same, size is same, because M is equal to, we know that minus V by U. Then if V and U both are same, then this is equal to 1. Then if M is equal to 1, that means the magnification is equal to 1. magnification is equal to 1 means the size of the image is same, and the negative of magnification signified that the nature of the image is inverted. Okay, inverted. The nature of the image is inverted. Okay, and this is real also. This is real also. This is from in front of the mirror. They are actually meet at the position of B dash. The rays are actually meet at the position of B dash. So the nature of the image is real also. Now, if the object is going towards the mirror in between center of curvature and the focal length, this is our fourth condition, that if the position image is formed beyond C, if this is F and this is C, and suppose to be object is considered if the object goes towards the mirror, first object is considered at infinite, then object is considered in between infinite and the center of curvature, then the object is considered at the center of curvature. Now the object is in between center of curvature and the focal length, just like this. Now if this kind of paraxial ray, this is not like to a parallel, suppose this is a paraxial ray which is incident on this point and it goes through focus. Okay, we can draw this ray like this way, and another ray which is incident at the pole and it's reflected from this point. It's curved like, should be curved. Then these two rays are actually meet at this point, so that the image of B dash can be formed, and this A dash can be written like this way. Okay, so now here we see that first thing that the image is formed, where the image is formed behind, where the image is formed beyond C. The image is formed beyond C, or image is formed in between center of curvature and infinite. Okay, now the second, this is also real. This is also real and inverted. And the nature of the magnification, what is the nature of the magnification? Nature of the magnification, we look here that V greater than U, at the V greater than U. If V greater than U, then M is equal to, we know that, minus V by U, that is M is greater than this one. This minus sign is signified that the image is inverted, and greater than 1 may signified that the image is enlarged. Image is enlarged, inverted. Okay, this is the actual nature of the image when the object in between C and F. Clear? Now if the position of the image, position of the object is going towards the mirror at the focus point, if we consider the position of the object at focus at F, then what happens? The position of the object at F, this is our fifth condition. For the fifth condition, for the position of the object U equal to F, position of the object on the focus. This is our F, this is our C, the position of the object at focus. Then from the position of the object we may write that those kind of rays which are incident from the position of the focus, the reflected rays should be parallel to the principal axis, because in vice versa, when parallel to the principal axis rays are incident on the mirror, concave mirror, then those rays are actually meet on the focus point. And from the reversible property of light, if the rays are incident from the focus point, then after reflection those rays are parallel to the principal axis. And if those rays are parallel to the principal axis, then they are may actually meet at the infinite from the mirror. Okay. Then if we can use this formula to detect the position of the image also, 1 by v plus 1 by u is equal to 1 by f. If we put that u is equal to f, then we get the v is equal to infinity. 1 by v is equal to 0, that is v is equal to infinite. What do you mean by the v is equal to infinite? V is equal to infinite means the position of the image at infinite. Okay. Understand? So the position of the image is, if the position of the image is infinite, then the magnification of the image is very large. The magnification of the image is very large. At the infinite, the magnification, because m is equal to v by u, and it can be also a real. Okay. And it may be virtual for the convex mirror. Now the sixth condition, that is object is going towards the mirror, now in between f and pole. Now the object is placed in between f and pole. Only for this case a concave mirror can be formed a virtual image by this way. Suppose this is our paraxial ray and it should be goes through this f, and if this goes on like this way, and the second ray which is incident on this pole, so if this can be reflect along this direction, then the nature of the ray, look here, this nature of the rays, they are actually, when goes away from the mirror, apart to each other, then they cannot be meet in front of the mirror. They cannot be meet, these two rays cannot be meet in front of the mirror, and it may be meet just behind the mirror. If this ray is look here from this point, then this ray seems to be coming from this direction, and these two rays are may virtually meet at this position. So in that case, only for this case, a concave mirror can be form a virtual image. So this is our interesting case, that the concave mirror can be form a virtual image only for this case where the position of the object in between f and p, f and the focus point. So this is the first condition, the position of the object behind the mirror. It should be behind the mirror. Okay, it should be behind the mirror. And the second this is the second is, it should be virtual and enlarged, virtual and erect. Virtual and erect. Erect means soldier, the height of the mirror at the same direction with respect to the principal axis, and the magnification, this is larger. Actually this the height of the mirror is larger with respect to the object, that the image is magnified. M is greater than 1, and mathematically we can show that how the M can be considered as greater than 1 by using the relation 1 by v plus 1 by e is equal to 1 by f. If we put the value of u is equal to f minus x, and if we calculate the value of v, then we get finally that the value of v is greater than x, greater than f. If the value of v is greater than f, then m is, you know that m is equal to minus v by u, then m is also greater than 1. And if m is greater than 1, then the nature of the image is larger. Okay. So this kind of situation may be happen for the concave mirror. First the object is considered to be at infinite, then in between infinite and the center of curvature, then at the center of curvature, then at the center of curvature and the focal length, then at the focus point, and finally in between focus and the center of curvature. Those are the conditions for the concave mirror for different position of the object, how image can be formed. Understand? Is this clear now? Now the image for a convex mirror. How the convex mirror can be formed by an object. Suppose we draw first a convex mirror. The inner position is shaded and outer position is reflecting portion, and we know that the position of the focus and position of the center of curvature just behind the mirror. Okay. Now if we consider an object like this, suppose AB, and this paraxial ray is incident from this B point, and it should be reflected away from the principal axis. This is the diverging property of reflected light, and it seems to be coming from this point. This is the focus point. Suppose this is to be considered as focus. Okay. Now another ray, if we consider that incident at the pole of the mirror, then they are reflect along this direction, and if you look these two rays which are actually reflect from the convex mirror, then these two rays are apart with each other with respect to the direction of the incident rays, and they are never to be actually meet in front of the mirror, and it can be virtually meet. If we look here this ray, then this ray seems to be coming from this direction, and they can virtually meet just behind the mirror. Okay. So in that case the image can be formed just behind the mirror. Okay. So what is the position of the image? First behind the mirror, and we know that when the position of the image is behind the mirror, the nature of the image always virtual. The nature of the image, and from this ray diagram we can see that the nature of the image is virtual also, and the height of the image at the same direction with respect to the principal axis. So this is also erect. And the size of the image is smaller. What? The size of the image is diminished.
There are only two cases of convex mirror.
This is the only one condition for the convex mirror. For any position of the object in front of the mirror, if we take any position of the object in front of the mirror, then this kind of image always form for a convex lens. And for the concave lens, there are these 5 or 6 numbers of situation can be happen, and for the concave lens, this is one situation, that is the only one situation of the image can be formed. This kind of image always form for a convex mirror. Understand?